Hello, my name is Jay Carpenter. I'm founder of Desert Blockchain and Desert Blockchain Camps. And today is our Citizens Workshop, which also includes just community members if you're not a citizen. But we're going to be showing some pretty fun stuff using Stellar, Node-RED, Raspberry Pis, remote control of devices, and a lot of fun stuff. And we're going to be going over the basics with Shane Sandler, and Shane's going to be showing you some interesting things that you can do, that you can create. If you're not familiar with these workshops, you're not familiar with Desert Blockchain, let me stop my screen sharing. But we are the largest community of decentralized and blockchain folks in Arizona. We have over 2,200 members, and we're having these regular sessions on Saturdays from 11 a.m. to 12 noon, which is Arizona and Pacific time. And we are in Desert Blockchain Camp, which I'll show you a little bit of in just a moment. And you're welcome to join us on the live stream, or you're welcome, if you're a citizen, you're welcome to join us here in person from 11 a.m. to 12 noon. And we also encourage you to bring the youth in your life, your sons, daughters, grandchildren, and introduce them to decentralization, the Internet of Things, cryptocurrency, as well as other contemporary constructs. So I'm going to just kind of slowly turn my camera a little bit and show you a little bit of Desert Blockchain Camp. That is Shane in his site, and what we're going to be doing today is we're going to be showing some ways to remote control devices where you can log in and hit targets from anywhere in the world using the platform that Shane has created. And by the way, this platform and the project, it had recently won a hackathon that was related to Stellar. So at this point, I'm going to turn it over. Oh, we have not started recording. I'm so sorry. Okay, okay. We are recording on live stream, but I just started recording via Zoom. So check the live stream. The actual live stream link will be edited down so that it will start right at our starting time, and that's your best source for getting this information. So I won't go over the introduction again, but I will turn it over to Shane. And Shane, you can basically start the demonstration, the workshop, and show us some fun stuff.
Sounds good. Thank you for the intro, Jay. So I've got the link here in the Zoom call. I think Jay's going to post it to the YouTube live stream if anybody wants to download the demo project file and they can follow along and build what we're going to build. I'll go ahead and give you a quick little demo here, and then we will dive into actually building this little front end. If you're not familiar with Node-RED, then please check out some of our previous sessions where we show you how to fully set up a new Raspberry Pi on Node-RED. And there's plenty of other great tutorials for Node-RED and Raspberry Pi all over the internet. So we are going into this assuming you have Node-RED running on your Raspberry Pi. All right, I'm going to go ahead and share my screen here so you can see what I'm working with. Okay, I've got to reduce my window size just a little bit so I can get to my tabs. All right, so this is what we're going to be building today. It's just a basic flow so that you can control the GPIO pins, which are just like little data pins on a Raspberry Pi. That's how all of this device works. So I'll show you right here. When you click on the fire button, it triggers the GPIO pin, which triggers a relay, which then releases the valve for that pressurized water. And that's just the general workflow for how these work. So you click the inject, and it basically triggers the GPIO pin. And that's all that the Raspberry Pi is doing. For you to get a little bit of an idea of the hardware we're looking at, this is what the actual electronics on the device board looks like. This is the Raspberry Pi here in the middle, and you can see the pins that are connected to the relays here. And these relays are what are outputting the actual power to the various valves and actuators that actually drive this turret. So just to give you a little bit more of the demo here. So, we go left. It's easier to see if I either go full screen or while the water is shooting. So we'll go turn that on. And then as you click up, you can see how the water stream raises. And we've got actually 2 different water streams on this one. So you can see it moving there. Let me go ahead and give you back the full screen of the webcam so you can see it a little bit more clearly. Let's see here. Let me go back to this, and yeah, you can see it moving. You can see how it's being triggered. Okay, so that is a basic idea of what we're going to be building today. So let's dive into the code. All right, so this is the flow we're going to build today. Like I've said, it is posted if you want to download it to follow along. Here is where it's posted in the Node-RED library. So if you want to copy this right into your Node-RED instance, all you have to do is copy it from that site and go to import, current flow, and you can paste that JSON object in. And why don't we see it? Interesting. I told it to import it to this flow, but it looks like it created a new flow. So that's okay too. I thought I'd said current flow, but new flow is just fine. So here it's imported that flow, and you can follow along with it, or we'll just go ahead and get started building it from scratch here. So the first thing that I want to show you is how to just create a basic inject to trigger a GPIO pin on the Raspberry Pi. So you take your inject here, and that basically just gives you a button so that you can trigger things. And this all is working over our local network here in the warehouse. This instance of Node-RED is actually running on this Raspberry Pi that's connected to the turret. And I am actually editing this from a separate machine that is just connected to the same network. That's how we're doing the live stream. I'm pushing all these cameras and blending them so you can see multiple camera views on this machine. So this won't give us a front end that's accessible over the greater internet, but only on your local area network. And so then if we look back at this, so basically our goal is to create a button that can trigger the GPIO pin to change from a 0 to a 1. That's what these pins in the Raspberry Pi are basically just waiting to be either a 0 or a 1. And then that little bit of current triggers these relays to release a much larger amount of current to the devices that we're actually trying to run. And then they don't even have to be the same voltage either. For example, this relay over here is actually triggering 120 volts AC, so that the aquarium pump, or it's really a fountain pump that can run off of non-pressurized water, can run. So, so we're going to be using an inject to create a 1 and then to trigger the GPIO pin. So we've got our inject here, and then what we're going to do is we're going to take this inject, and instead of injecting a timestamp, what we want to inject is a number. We want to inject a 1. So that's going to send a 1 to, now we've got to go down to our Raspberry Pi pins, which are all the way down at the bottom. You can also search. Apparently you can't search Raspberry Pi, but you can search GPIO. And so we're going to take our 1 and send it into our GPIO pin. And then if we want the ability to turn it off, we're going to need a 0. So we'll go ahead and get another number. And we'll give that a 0. And what you're seeing here is that the actual inject is sending 2 different portions of the message object. So in Node-RED, it's whenever you tie these different nodes together, you're just basically telling it where to send this message object. And so this message object has 2 different variables. It's got the payload variable and the topic variable. We don't really need the topic variable for what we're doing, so we can just remove that if we want, and you can add as many variables into the message object as you want. So there's our 0, and we'll be able to send that to the GPIO pin. When you're building your actual hardware to go with your Raspberry Pi, you've got to pay attention to what pins you're actually connecting to, so you're triggering the correct ones. Since I've already got this built, I can just look at the old one. And so I want to use this to trigger this water gun, which this is on GPIO 21, which is pin 40. And this pin layout corresponds to the physical pin layout of the actual Raspberry Pi. I'll go ahead and show you real quick. I'll go back to the full screen webcam here. Let me pull up my full screen cam. So this is what the Raspberry Pi looks like, and you see these pins here. That's what these 40 pins that are corresponding to the pins that are in the Node-RED flow. So this 40 pin that I'm dealing with right here is actually the bottom pin right down here. Okay, and I'll go ahead and share my screen again. All right, so this 40 pin is that bottom right pin, and that you can see is connected right there to this relay here, and that's what's triggering the valve that holds back the pressurized water. It's really just a sprinkler solenoid valve is all that it is. So we're going to go ahead and get this on the pin 40, and we want the initial pin state to be 0 so that it doesn't trigger as soon as this Node-RED flow turns on, and we will be done. And so now we have to deploy this, and that will go ahead and push these changes to the actual Raspberry Pi. And now we should be able to use these inject buttons to turn that water flow on and off. And there we go, on and off, on and off. So that's like the most basic way you can control devices using a Raspberry Pi remotely. So in order to build a slightly more robust flow, like what we're looking at here, we have to get a little bit more involved. So what you see here, so this is basically what we just built right here, is just this little firing command, but we built a simpler version of it that we have to manually turn on and off. This version incorporates a 5-second delay and then automatically turns it off. So you can just fire off a fire command, it'll shoot for 5 seconds and then immediately deactivate. So let's go ahead and replicate that. So what we need to do for that is add in a 5-second delay and a reset. So instead, I'm just going to go ahead and actually copy and paste this so that we can see the comparison. So instead of having our 0 as a button, we're just going to set it up so that the 0 comes in automatically. So we're going to add a delay node here. And I like 5 seconds for these water guns. That's a good amount of time to spray some water out. So at the same time that we trigger the 1 into the pin, we're going to trigger a 5-second delay. And then we're going to use this change node to change the payload from a 1 to a 0. So it's going to take the payload and change it to a 0. And we will wire this all together. So functionally, what happens when we click this button is it sends the 1 to the GPIO pin, which will trigger it, and it'll send the 1 to this 5-second delay, and it'll wait here for 5 seconds. You'll see a 5-second countdown, and then once that delay is over, it'll send that 1 to to this message change node, and this change node will change it to a 0, and it will send it to the GPI open. And that will give us a 5-second fire without having to turn it off. So let's go ahead and deploy it. And then you can see, oh, it doesn't show you the countdown when it's not a variable. When it's a constant delay here, it just is it. But when you do a message.delay to send a specific delay into that node, it'll actually show you the countdown underneath it. So that's kind of a cool feature. So that is your basic firing mechanism to get something, just a very simple on-off type of switch going. So that is actually much cleaner code than I wrote here. It looks a lot better in my opinion. Because in this one, basically this inject is just firing nonsense. It's just firing the timestamp, and that has to first be turned into a 1 before it can be sent to the GPIO pin. So this is actually a cleaner way to do it. So that works really well for something simple that's just on off, but for the left, right, and the up, down, those are running off of linear actuators, which actually have a directionality to them. So you basically, you have to reverse the flow of the electricity in order to get the two different directions. So that's why I'm using these types of relays. These are, I think they're LN298Ns. I'll find a link to the ones that I bought, and we'll post them up somewhere so that you guys can find them if you want. They're very inexpensive on Amazon, and they basically allow you to take a single power source and invert the polarity so that you can get both directions that you need in order to control an actuator in both directions. So that requires 2 GPIO pins, and you want to make sure that they aren't ever both set to 1, because then it can be triggering, it can basically fry your linear actuator if it's trying to send both directions at the same time. So that's why the flows for the left, right, and the up, down are a little bit more complicated, because we have to control 2 pins simultaneously while making sure one is at least one is always at 0. They're never both at 1. So let's go ahead and walk through how to build a flow like that. And we will build it kind of sequentially, so it won't immediately look this complicated. So we'll go ahead and we'll grab, well, we can actually just copy our 1 inject node again, since we've already got that set up. And then we need to get another GPIO pin. We actually need 2 pins for this, like I said. Let me go ahead and take a look at what those pin numbers are. We'll go ahead and do the up down first, because it's a little bit more obvious from this angle of the camera when we're firing. So we're using 16, pin 16 for our up, and pin 18 for our down. So I could actually just copy and paste those from here. It will be a little bit easier. Stick those there, remove these. So we've got our up set to 16 and initialized at 0. And our down on pin 18, initialized at 0. So if, let's say we want to go up, we can just wire straight to the up node. And at the same time, we want to make sure that the down is at 0. So we can, so one thing that makes things a lot easier when you're looking at your flows that you're building is if you actually set these names so that you know what it does. So now we can see here that's setting the payload to 0. So now we can just look at that and know what it does. So that's what we need. Oh, we didn't get that copy quite off. All right, I'm just going to do a control copy, control paste. And so that at the same time, we'll make sure that this other pin is set to 0 so we don't fry anything. And then just like the other one, if we don't want to have to manually turn it off, we need to introduce a delay to turn it off for us. So we can copy that and paste it. And we can actually drag these in. Sometimes it'll actually let you snap it right into the wire, but it doesn't always want to let you do that. So you might just have to rewire it. Oh, actually, I am screwing up here. We needed that. So that we want that to actually trigger the 1 immediately. And then we want it to wait and then trigger it back to a 0 after, let's say, 2 seconds. Okay, so now when we push this button, it's going to immediately trigger that up pin, and then it's going to make sure that down pin is on 0, and it's going to wait 2 seconds and then untrigger the up pin. So we'll go ahead and push that out. And it'll be a lot easier for you guys to see this if the water stream is actually firing. So I'm going to go ahead and trigger that and trigger that. And so you can see it moving down, and now it's done. Great. So now we just need to build the same thing for up. So it might be easier if we label this. So we'll name that down. And then we're going to go ahead and rebuild the same thing, but in reverse. So we'll take this node, we'll paste it, and this is now going to be up. And for the up command, we need it to immediately, let's move this out of our way. Needed to immediately trigger the down. So I got these pins backwards. So let's go ahead and relabel these so that we can not get confused. This is down. This is up. And those could have been reversed physically as well. So we either could have changed the pins here to reverse that, or we could have physically changed the wiring on those pins to reverse it as well. So we have a few ways to potentially reverse things like that, but it's usually easier just to relabel things. Okay. And so now this, when we hit this up, it's going to send that 1 right to the up. We need it to also immediately send a 0 to the down pin so that we don't accidentally send to both. And then we need a delay that will reset this pin to 0 after 2 seconds. So we'll go ahead and wire that in. All right, so now looking at this flow, if we click this button, it'll immediately trigger the up. It'll immediately trigger a 0 on the down, and it'll wait 2 seconds and then reset the up. And that is exactly what we want. So let's go ahead and deploy it. Let's go ahead and trigger, we'll trigger the fire and we'll trigger the up. Yeah. I'll go back to a full screen view there. So we had a problem here that wasn't working, and I'm not sure why. It says it's successfully injecting up, but we're not seeing a 1 here being triggered on the pin, which is interesting. So what you see when we push the down here, oh, it should be changing that to 1. Why isn't it? Let's see. So now we're just doing a little troubleshooting here. Up should be triggering that. Let's see what pins. We got 16. We've got 18. I'm not sure why that's not triggering. Let me come back to my other flow. Trigger up. So I see the cannon physically moving, but for some reason, it's not doing it here, which is interesting. Let's see. How shall we troubleshoot this? Well, so one way to troubleshoot it is to simplify. We will just copy these 2 nodes and just see. Oh, actually, what we can do is we can go back to this little on-off switch that we built here and just change the pin. So the pin that we want is 18. So we'll change this to pin 18 and see if we can on-off trigger the up portion of this flow. So this should trigger up, and I see it moving, and that turns it off. And then we've got down, which isn't working. So apparently I screwed up somewhere in my flow here. Let's troubleshoot it and figure it out. So, oh, it's because I set this to, I built this a little bit wrong. So this payload 0 that it's intended as the reset to make sure that we don't accidentally send ones to both pins is actively sending zeros to both pins. So I need to make this, I just basically need to make this different so that it only does it to 1. So this 0 is intended to be sent to, so when we trigger the down, it sends the 0 to the up pin. And then when we trigger the up, we need a different 0 to send to the up pin or the down pin. So this will be like that. So that was my error on that. I was actively sending zeros to both pins whenever I triggered this. So that's why one of my favorite things about Node-RED is you can visually see what your problem was instead of having to dig through all your lines of code there to try to figure out where your error was. So let's go ahead and deploy that. And now we should be able to see our up and down working. Oh, so that is, so I changed that off of the firing mechanism. So there's fire, which some reason isn't working now. But our down is working and our up is working. For some reason, our fire stopped working now. Interesting. Well, let's go ahead and switch this over to the other pin for the other firing mechanism and see if that one wants to play nice with us. So that's pin 38. We'll switch that to pin 38. Done. Deploy. Trigger that. And that triggers our little, and then we'll go down so you can see it moving. Oh, we lost our firing. Trigger that again. So you got your up trigger, you got your down trigger. All right, great. Let me go ahead and show you that in full screen so you can see it working. All right, we're back to full screen here. I'm triggering the blaster, and then we'll go up. There we go. We got our up pin working. I'll trigger it, shoot some water again. We got our down pin. There you go. So now you can see a basic control circuit for how to build this stuff. And that is the basics for how this works. So to create left, right, let me go ahead and pull my screen back up for you. All right. So now to create left, right, all we have to do is copy paste this and change the pins because it's the exact same flow. It's just a couple of different pins for the left, right actuator. So our left, right pins are pin 11, and I'm going to guess pin 13. That's correct. Pins 11 and 13. Right. So we'll go ahead and change this to 11. We'll change the name to left. Change this to 13. Change the name to right. Go ahead and change the names of the injects as well so that we know what we're doing. All right, and that should work. We'll go ahead and deploy that and see what we've got. Left. Oh, so these are backwards. So that's giving me right, and this is giving me left. If I shoot the water, you guys might be able to see it a little bit better. So that's going right. So we will go ahead and this time we'll just reverse the pins so that I don't have to relabel 4 things. I just have to do 2 things. So we'll just go 13 and 11 and we'll deploy it. And we'll go left, and there we go. Now we've got left. And we've got right. Perfect. All right, so we've basically got this functioning. If we want to, we can also, since we've got 2 different firing mechanisms on this, we can duplicate this one as well. And we can change this to back to pin 40, and we can label this hose sprayer, because this is the one that runs off of the pressurized hose water. And then this is the one that runs off of the fountain pump off of the 120 volt AC. So let's just call this fountain sprayer or fountain fire. Go ahead and deploy that. And we can see our fountain machine there. Looks like that one bucket's about out of water. We need to get a little bit more water in there. And so let's see why our hose fire is working again. Not sure why that stopped working for a little bit. But there we go. We're in action. So this is basically a rebuilt version of this. It's basically a control circuit that allows you to get, your left, rights, and your firing mechanisms. I was very, very tempted to hit the fire button there as Jay walked out in front of it. Okay, so that is the basics for what I wanted to walk through today. We've got some extra time here, so I think what we should do next is expand this out, and I can show you how to build a basic graphical interface, like sort of a whole front end that you can. It's still only a it'll still only be accessible on your local network, but you can create a much prettier front end for this using the dashboard nodes. So let's go ahead and start working on that. So dashboard is not natively, is an additional package that isn't natively installed. So if you don't already have your dashboard installed, which we walked through in the last tutorial. So if you did that, you should have it installed. But if not, you come to Manage Palette, Install, and then you just type in dashboard. And you want Node-RED dashboard right here. This is what you're going to install. You can see it's already installed on my machine. If you click the expand button there, it'll show you the whole walkthrough of it. So dashboard is a wonderful, wonderful node package for Node-RED that allows you to create all sorts of beautiful UI type stuff. You can create gauges, you can create buttons, you can create pie charts, you can create all sorts of awesome stuff for the UI here. So let's go ahead and start up building a very basic UI here. So the dashboard nodes are most of the way down here. You start getting into your dashboard nodes right here, or you can search. So you can't search by the category, which is unfortunate. Maybe Node-RED will implement that a little bit later, but what we're looking for is a button, which this is the dashboard button. So we can drag, I didn't mean to. So that's why I was saying you could snap it right into the wiring. I didn't mean to do that though. I want to just put it right there. So this button is going to basically replace the inject. And we can even leave the inject there if we ever want to drive it from this sort of back end view. And then the button and the dashboard and the UI there will be our sort of front end view. So if you chose to scroll down to the dashboard, button is the very first one. So we can go ahead and name, okay, so this is going, since I've got a few other nodes in here, you're going to see some extra, or a few other flows in here. We're going to see some extra stuff. So it might be easier if I actually delete out some of this other stuff so that we don't have so much noise when we're looking at some of the dashboard stuff. Let me go ahead and delete out some of these. Are all the flows that you can import. These are all from the Stellar SDK. And they have quite a few different dashboard. Before I redeploy this, I can show you real quick what that looks like, because those will all still be there until I redeploy. So when we're trying to access our dashboard, it's the exact same way as accessing the Node-RED, but it's /UI after the :1880 after the IP address. So all of this that you're seeing here is built through those dashboard nodes, and you can even create multiple groups. So each of these little categories on one I'm forgetting the term. It's like a tab, or these are groups, and then these are all separate tabs. These are all created by that dashboard. So we will go ahead and come back here, and we're going to go ahead and we're going to create a new UI tab. And we can just leave it default. We can go ahead and change those later if we want. So this is going to be water cannon. Update. And so this just basically gives us a home for our UI. And our button, we want to call it fire. And we want to name it fire in our backend. And we'll go ahead and push done. And so we basically need this to do the exact same thing as the inject was doing. So we're just going to wire it to be identical. So we're going to wire it to immediately, actually I forgot. So this, and then when clicked, we have to set it up to send a payload of a number of specifically the number 1. And we don't really care what's going in the message.topic because we're not using that. And so then now this is going to basically do the exact same thing as the inject. It'll send a 1 to that pin, and it'll send a 1 to this delay, and that delay will send the 1 to this change node, which will change it to a 0, and then send it to the pin, back to the pin. So we'll go ahead and deploy that. And now we can see that our UI has been updated. We don't have any of those tabs that we deleted. All we have is this fire button. And there we go. It's doing the exact same thing. You can see it spraying there. So I'm going to go ahead and click it and then jump back to the back end here so you can see what's going on. So you can see that the pin is triggered. It's at that 1 state. And also, if you want to get any feedback on your back end, you can use this debug menu here. In order to use that, you have to use these debug nodes. This is the most common way to sort of troubleshoot. And if you're just trying to figure out while you're building, is to use the debug nodes. So you can take, if you wire into the debug nodes, you can basically see here what it's doing in the back end and sending the stuff. So what we should see in the debug screen after wiring this is right when we click the fire button, it'll send, we'll see in the debugger that the message.payload is getting a 1. And then after 5 seconds, we should see that it's getting a 0. So let's go ahead and deploy that so we can see the debug. We'll go ahead and push fire. You can see here that it just received the number 1, and in a couple seconds, it should receive the 0. And there you go. So then you can see on the back end, you know, if you're trying to troubleshoot or once you're working with more complicated functions, those debug nodes are absolutely essential, super, super useful for seeing what's going on the back end of your program. Okay, so we can go ahead and continue building out this UI. We need, 5 more buttons. We need the secondary fire, and we need up, down, left, and right. So we can go ahead and copy and paste these buttons because that will keep all of that data that we built as far as where in the UI these should go in there, so we don't have to rebuild all that. So we'll call this fire 2. And we will wire it up the same way as the inject node. We'll go ahead and paste it in 4 more times for these other functions. We'll go ahead and rename them all. We'll do down. Up. Left. And right. And the same as the others, we just have to wire these into the actual functional flows. So when I'm trying to match things, I'm looking, I see there's 3 wires coming out of here. So I just want to match them. So 1, 2, and 3, and 1. Oh, I didn't need to redo that. And it looks like it didn't because you can't wire it twice to the same node. That was already the inject node. I need to do the button. 1, 2, and 3. Oh, come on, mouse. And sometimes when wires start to get close right there, you can get a little bit confused to see what's actually connected to what. So sometimes you want to, so yeah, that's correct. We've got the wire coming from both the inject and the button. So sometimes you just want to move things around just to make sure that you've actually gotten things connected up correctly. 1, 2, and 3. And that one's already wired. We need the button. 1, 2, and 3. All right, so a little quick check. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. This one looks like it only has 2. Oh, yeah, because these are the firing buttons. These ones don't have the resets in them because we don't have the complexity of the back and forth motion. Okay, so that looks pretty good. So we can go ahead and deploy it. Go ahead and look at our UI. Now you can see all of our buttons here, and we can actually, after we make sure all the functionality is working, we can go ahead and make this much prettier and organize everything the way we want it to. But let's see if everything's working. So we got fire 1, fire 2. Those both work. Up. Wonderful. Let's go ahead and trigger those fires again. Down, up, left, right. And trigger those fires again so we can see the right, left. Oh, looks like I didn't change this right button to have the right label. So let's go ahead and fix that label. But all the other labels look good. So this right button, I forgot to change the actual button on the actual label on the front end to right. I did it on the back end here. That's why you can see that it says right, but the front end needs to say right as well. Okay, cool. So let's deploy that real quick so we can just see that label. Now you go, there we go. So now let's rearrange these buttons to make them a little bit more intuitive. So you can work with your UI arrangement directly in this menu. But I actually prefer, there's a hidden little icon here, the dashboard icon. If you actually expand out your right menu here, then it'll pop up there. And this is my preferred method for editing. This is all that old stuff that we deleted out all these tabs, or all these tabs from the actual backend when we deleted out all of the Stellar SDK, but it didn't actually delete the UI tabs. So we can, actually, I don't know the best way to delete these. It looks like we have to do it manually like this, make things a little cleaner for what we're looking at here. So yeah, it still had all the UI kind of floating around in the back end there, even though we deleted the actual flows that controlled them. It still had all the UI arrangements. So we'll go ahead and remove these. This is my preferred way to edit your dashboard UI. Like I said, it can be done from this menu, and we probably will have to come back into this menu for some things, but this view works a lot better for me. But that's just personal. So we can go ahead and change the home label, which that's this label here, which really only matters if we have multiple tabs here. But for ease, we'll go ahead and name this water cannon control or UI. And then you can see here that this group is called water cannon. That's what this is here. So like if you add another group, then we would have another basically menu here. Look, sort of just an arrangement there. So we'll go ahead and remove that. Okay, so as far as these actual buttons go, so the fire button, the way I would like this to look, let's say I want the 2 fire buttons next to each other, and then I want the up button, and then I want the left, right buttons next to each other, and then the down button. That seems like sort of an intuitive arrangement to me. So first, we can change the width of this tab, but it looks good to me. We don't really need to, but let's go ahead and give it a set width so that things are a little bit easier. So we'll go ahead and edit this group, and we'll say that, yeah, I like 12. 12 is a good width. And then we'll go ahead and make each of the fire buttons 6 wide so that they can sit comfortably side by side. And then let's bring the up button up, and we'll bring the down button down. And let's make these all 6 as well. Actually, if I make them 6, then we might have to do something to keep them arranged. So let's go ahead and just make the left right buttons 6 wide and see what that does to our arrangement. Okay, and we'll go ahead and deploy that. And there we go. So it's not exactly how I wanted it to look. We can bring in some spacers and stuff to change this, but it's getting much closer. So we've got our fire button, our left fire, our right fire, our up, our down, our left, and our right. So this is a much more intuitive arrangement. We can certainly clean it up a lot more if we wanted to really dive into what all this offers. I'm not totally sure why it's putting these spaces in here. The dashboard is very powerful, but it is not necessarily the most intuitive thing to work with. I mean, as far as front ends go, it's pretty good in my opinion. Let's see. I'm wondering if it has to do with the size being auto. Maybe if we just make them say 10 wide. Let's see what that does. Go ahead and deploy that. It didn't center them or get rid of those spaces. So, you know, this is where you can just kind of get into the fine tuning as you play around with the dashboard. It's a very powerful node package that you can bring in. And, you know, this basically shows you exactly how to build a very basic control interface for something that's running off of your Raspberry Pi GPIO pins. So, like I said, this one is triggering relays. So basically these pins are triggering relays, which using relays, you can have a ton of functionality from controlling any number of devices, from valves to lights to all sorts of things. And then, you know, that's just one aspect of what you can do with these pins on the Raspberry Pi. You know, relays are just one of an infinite number of things you can trigger with these pins. You know, they can send data back and forth. You can actually do inputs as well, because these, all we've shown today is just outputs. So the possibilities of how this can be used are pretty much endless. It's a very robust tool and system that can be used for all sorts of fun. So I'm going to go ahead and stop screen sharing so you can see full screen while I go ahead and click on some of these buttons. And I think that's about all I have to show for today.
Shane, do you mind showing a little bit about Stellar, how this integrates with Stellar?
Sure, absolutely. Hang on, let me just show you this real quick. So we've got the full screen here of the webcam, and I'll go ahead and just start clicking some buttons. We've got our fire, we've got left, we've got down. We'll click our secondary fire, send it up, send it right, click the main fire, left, down, right, fire 2, up, right, up. Cool. So let me come back into my screen share here and talk a little bit about how this can be integrated with Stellar. Where's my Zoom? There it is, screen share. So, so all of this, so the dashboard explicitly can be used. Let me go ahead and pull that Stellar SDK back in. So we can go back to the Node-RED library and we can type in Stellar. And we can go ahead and grab my Stellar SDK here. We'll copy this. We'll bring it into Node-RED. Import, new flow, paste, import these copies. Okay, and we will go ahead and deploy this. Interesting. Not sure what's going to happen with that. Let's see what it did. So it doesn't have everything it needed to deploy properly, probably because I deleted all of, I deleted all of the UI groupings that it needs. So I can just go ahead and let's see, assign them to a new UI group real quickly.
It's okay. You don't have to really.
Okay, but yeah, so
set it up.
basically,
just talk a little bit about how
sure.
it can
Yeah, so
tie
basically
into Stellar.
what you saw a minute ago when I had the Stellar UI up here is that all of these buttons on the dashboard are connected to functions that are not necessarily connected to the Raspberry Pi. So you don't have to use the dashboard to trigger a Raspberry Pi GPIO pins. You can use those dashboard buttons to trigger anything in your flows. So for example, in some of these Stellar flows, so there's there you can put in input fields, like I said, so the dashboard doesn't have to be just one way, it's input and output. So you can use the dashboard to ask for a public key, and then you can use that to say, check the balances of an account. So when someone puts in a public key into that dashboard, you can trigger a functional node that submits that public key to it's called Horizon, which is on Stellar. That's the API for accessing data on the Stellar blockchain. So basically that will send the public key to the Horizon server and ask it, what are the balances of this account? And then it can output that back to the dashboard, and you can display that information either via text. You can use a gauge, you can use pie charts, you can display that information in all sorts of graphically beautiful ways. And you can get much more complicated than that. So some of these other flows here use the dashboard to fully send transactions. So you just need all the information input. So for example, to send a transaction in Stellar, you need the secret key for the account that's trying to send. You need the destination for where you're trying to send it to. Since Stellar allows for multiple assets, you got to tell it what asset you're trying to send, whether it's the native XLM lumens or if it's a custom asset with its own issuer, and how much you're trying to send. And then you can also do, this is an optional field. You can add a memo to your message. And that would be all the information that would be needed in order to submit a Stellar transaction. And so then once you push the button to send either your tokens or your XLM, the flow both resets the fields that actually display the textual feedback and actually goes ahead and submits all the information needed to actually send a Stellar transaction. And you can use this for, not just for Stellar or anything, like for example, this flow here accesses the Kraken API, which Kraken is a cryptocurrency exchange, and it gets you live prices for, any sort of cryptocurrency you want, whether it's Bitcoin or Ethereum or Stellar, you can get, and it displays it all in nice, pretty gauges that shows you, what the price action is doing. So you can use this dashboard in an incredible amount of different ways, for interaction to simply just displaying information. It is extremely robust. Is there any other particular things you wanted to talk about today, Jay?
No, well, I'd like to just wrap it up.
Sure.
And, we'll talk a little bit about the workshop next week, as well as the Desert Blockchain monthly session.
Good. So I think that's about all I've got for my tutorial today. That should give you a pretty good idea of how to use Node-RED to build a basic control flow for either a Raspberry Pi or for using the dashboard to build, other applications that you want to build. And thanks for following along, and hopefully we will have more information that you find useful coming up. So please let us know if you have questions or there's other things you want us to talk about.
All right, thank you, Shane. That was very cool. And I would like to mention to everybody that's watching this that we are having these sessions. That's really cool. We're having these sessions every Saturday from 11 a.m. to noon Arizona time, and you're welcome to join us on the live stream, certainly. And if you're a Desert Blockchain citizen, you can join us in person. And as I mentioned at the beginning, we encourage you to bring your youth, your sons, daughters, sons, granddaughters, and introduce them to some of these cool things that they can learn and get their hands on. And it's also it's a lot of fun to watch this stuff being remote controlled here in the Desert Blockchain Camp. And Shane hasn't really talked about it, but all of these things can be controlled via Telegram app at this point from anywhere in the world. So we're going to have more of these sessions, and we appreciate your time and your attention. I would like to mention, and I'll screen share a little bit myself, that we are having on next Wednesday, we are having a session about a $5 million funding opportunity for blockchain and wearables. This will be on Wednesday, July the 28th, and it will be starting at 7 p.m. Arizona time, 7 p.m. Pacific. We will have some folks from the Arizona Commerce Authority that will be talking about how this program works. It is matching funds, and it's a way to basically get an additional $250,000 on top of a $250,000 funding grant for applied research projects in either blockchain, wearables, or possibly both. So this is the second time that this funding mechanism has been available, and I'd encourage you to take a look at it. We will be looking at this and exploring it at the Desert Blockchain Camp in the future, and encouraging folks in Arizona to check it out and see what's available. So that's coming up on this Wednesday. Then again, on the following Saturday, which will be, I think it's August the 1st or 2nd, maybe the 31st. Anyway, whatever a week from today is, I guess it's the 31st of July, we'll be having another session, and we'll be exploring some of these powerful techniques, opportunities, and fun games and ways to control various devices. So thank you for your attention. Stop my screen sharing here, and we appreciate your feedback. Any suggestions you have, please let us know. But this is your way to learn about the decentralized space and build some things that can be fun and basically educational at the same time. So thank you everyone for joining in. I'm going to stop the recording and stop that, and